Okay, I hope you all had a refreshing coffee break after all the enticing talk that happened this morning. Um, it is our next keynote speaker does not per se require an introduction, but I do not get an opportunity to introduce a speaker of his stature every other day, so I will make good use of this opportunity. So Professor Y. Narahari is an honorary professor at the Department of Computer Science and Automation, Indian Institute of Science, Bangalore. The common thread in his current research is to apply game theory, mechanism design, and artificial intelligence in a principled way to research problems which are at the interface of computer science, economics, and social good. He has authored a book on game theory and mechanism design, which was published by the IISc Press and World Scientific in 2014. Professor Narahari is a fellow of IEEE and also a fellow of INSA, IASC, INAE, and NASI. Professor Narahari is a recent winner of the IASC Distinguished Alumnus Award and the prestigious Sir M. Vishweswaraya Award by the Karnataka state government. One of Professor Narahari's recent interests is to explore the application of game theory and artificial intelligence to digital agriculture, and especially that so in the Indian context. So he and his students in the game theory lab have developed a bouquet of algorithms for addressing variety of key problems in the agriculture domain in the Indian context. And he is going to talk about some of those in his keynote lecture next. So with that, it is my great pleasure and privilege to welcome Professor Y. Narahari on the stage.
Good morning. Thank you, Shaurya, for a very kind introduction. So over the next 40 to 45 minutes or so, I will take you through a rather interesting and I should say an accidental journey that I have made in the last 3.5 to 4 years or so on this topic of applying AI and game theory to some very important problems in agriculture. First of all, I would like to start by looking at some fundamental questions which were the driving forces behind our work. So way back in the, first of all, I should also thank ACM India for giving me this privilege and also an opportunity to be talking to all of you here. Thank you, ACM India. Coming back to this, way back in August 2020, so I introduced a course on AI for social good in consultation with Professor Milind Tambe from Harvard University, who was also offering a similar course. And after discussions with Professor Tambe, so in this course, which was actually taken by about 10 students, we actually covered 3 important topics of social good. One was, of course, healthcare, because it was during COVID time. The second one was on education. And the third one was on agriculture. But it turned out that during the course, the focus somewhat shifted completely towards agriculture because the students perhaps found the problems that were presented in agriculture as very interesting. So I think that was the starting point. And so during that time, there were many important questions that we wanted to ask about agriculture in general and Indian agriculture in particular. The first question is, if you look at the picture here, you are looking at tomatoes or onions or any of these perishable vegetables. Now, it turns out that if you are in any state in India, there is a situation where very often there is a glut in the production of these vegetables, because of which the farmers do not get the prices that they want, and they do not even have the kind of resources which are required to transport all the produce to the actual markets. And you can see there are situations like this which keep on happening, especially in the state of Karnataka for tomatoes. Okay, so the second question that we were looking at was, our Prime Minister actually talked about doubling the income of farmers in a 5-year timeline. Now, this will call for much better crop planning and also for crop recommendation. So, can we now develop some ways by which we can do crop planning better? We can do crop recommendation better, so that the agenda that the Prime Minister has set for the country can be, sort of at least attempted. Was another question that we were trying to ask. Of course, the third question that we wanted to ask was, can we make FPOs realize their potential? What are these FPOs? FPOs are farmer producer organizations. These are farmer cooperatives where hundreds and sometimes even thousands of farmers will come together, and what they want to do is, they want to exploit economies of scale, whether it is procurement or selling of the agricultural produce. So they would like to somehow do things much better than if they were doing individually. It turns out that in India currently, there are more than 60,000 such farmer cooperatives, of which more than 10,000 are actually sponsored by the National Bank for Agriculture and Rural Development in India. However, though it's an extremely romantic concept of farmers coming together, the concept actually has not worked. And only about 2 to 3% of the farmer cooperatives actually are prosperous. So the fundamental question is, can we somehow make this concept of cooperation among the farmers really work? That was the other question. So I think there was a bunch of other questions that were also raised, especially in the context of Indian agriculture. And when we wanted to look at some of these problems, I think there was an opportunity that came up sometime in June 2021, because of a chance meeting with Dr. P.V.S. Suryakumar, who at that time happened to be the Deputy Managing Director of NABARD. So NABARD is the central bank in India which looks after agriculture. And he was the number 2 in that organization. And this chance meeting happened because of a good friend called Dr. Ramana. And so I think in a 1-hour conversation, Dr. Suryakumar essentially convinced me, Professor, you should write a proposal to NABARD on some of the questions that you are trying to investigate as a part of your work in the department. So I wrote a proposal, and then I made a presentation to the NABARD team. It was an online presentation, and the NABARD team was thoroughly unimpressed with my talk. So they were wondering, what will this professor do for Indian agriculture? There is this Indian Council of Agricultural Research, which has more than 100 research labs, and they have been trying their very best to do something for Indian agriculture. But here is a professor who works on some esoteric aspects of game theory and mechanism design, and he wants to do something for Indian agriculture. So they were not convinced. But somehow I think Suryakumar had been convinced during that conversation. He said, Professor, don't worry. We have a board meeting coming up next week in NABARD. I will somehow get you a 15-minute slot in that board meeting, but you will have to impress the board members. So as you become senior, you become more adept trying to convince the board members rather than students who are actually trying to learn the subject and so on. So I think in the next 1 week or so, I actually prepared like a grad student or maybe an undergraduate student for a lecture that I was going to give to the board members. And next week when I gave that presentation, See, in life, you should always have luck on your side. So if luck is on your side, anything can happen. On that particular day, I think luck was very much on my side. So this 15 minutes presentation, I think the NABARD board members were actually clean bowled, and it actually became a 45-minute session. Not only that, in about a month's time, they actually sanctioned a big project for me to actually work on some of these problems. So I think in my over enthusiasm, I had actually promised the moon to the NABARD people. Now, how do I realize it? I need students to work on this, right? And getting students to work on agriculture-related problems in India's #1 computer science department is not easy. So then, what did I have to do? So I had to depend on project assistants who are like captives. So there was one CM Arun, project assistant. He has to work on whatever I tell him to work on. Then there was one Sanat Patil also, he had to work on whatever I told him to work on. And then finally, one MTech project student, Someshwar, he came to me because he's from an agricultural background. He thought, oh, this professor is going to do something for agriculture. Let me also try working with this professor. But I think the breakthrough came when this person called Inavamshi, who had just finished his master's in State University of New York, he was actually looking for some social good problems. And I had a chance meeting with him. Everything happens because of chance. Everything happens by accident. And this is something that has really happened by accident. And then the biggest breakthrough, I think, was Mayank Ratan Bharadwaj. So he was already in his third year PhD. The PhD was not going anywhere. So I told him, Mayank, if you work on agriculture, your PhD will be done in 2 years' time. In 4.5 years, you will do your PhD. And then he promptly fell into the trap. He said, sir, I will work on agriculture. And the problems that you have stated look to be very interesting. Okay, so then this team was there. So this team worked for maybe about 6 to 7 months, and we were able to do something interesting. But then because of the deliverables that I had promised to NABARD, I needed a lot more students. I needed at least 5 more students. But the MTech project students would not come to me, except Someshwar, of course. So then I work in mechanism design. So what I did was, next time when I announced the MTech projects, all that I said was I was working on price prediction, I was working on crop recommendation, I was working on crop planning and so on. I said deep learning based price prediction. I said deep learning based crop planning. I said deep learning based crop recommendation. And then as many as 26 MTech project students wanted to work with me. And I had the problem of plenty. I had to choose about 5 students or so. I think over the last 3.5 years, this team has actually become a very big team. And you can see that in about 3.5 years time, we are actually able to put together a team. Many members of this team are actually very passionate about doing something for the Indian farmers, because the number of Indian farmers who are small and marginal farmer essentially means you have less than 5 acres of land, and there are 20 crores, 200 millions of these farmers in India. So even if there is an epsilon greater than 0 improvement, if you multiply that epsilon by 200 million, the kind of improvement you are able to make can be huge. Of course, in all this, we were not agriculture domain experts. So I had to take the help of agri experts. So I contacted 2 very capable professors at the University of Agricultural Sciences, Bengaluru, Professor Lalit Achot and Professor Vedamurthy. And I also sort of engaged with the startup world. I suddenly realized that there's a very large number of startups in the agriculture space. In fact, in Bangalore alone, there are 250 startups in just the agriculture space. So I also sort of talk to some of the startups and see how I will be sort of able to deliver things that startups can actually take on from there. So I think we call the project as Grama. And if you look at this slide, it is full of acronyms. And these are fairly interesting acronyms. And this is what we do when we are jobless. When we are jobless, we always try to think about some interesting acronyms for the work that we are trying to do. So we have the GRAMA project. GRAMA stands for game theory. That's the area in which I work. Then R stands for random processes, because everything about agriculture is random. Then we have A for what else? AI. Then M for machine learning, of course. And then the final A for agriculture. So we have this GRAMA project. And then there are 6 building blocks in this GRAMA project. And these building blocks actually look at the entire life cycle of an agricultural farmer, starting from the planning stage all the way up to the harvesting and post-harvesting stage. So the first one, we call it as crops. It's basically a crop planning system. What it does is at the district level, or at the block level, or at the taluka level, it will come up with an optimal cropping plan for individual districts based on, of course, soil conditions, temperature, humidity, and many of these factors. It's a completely planning kind of a problem. Then the second system is called ACRE. It is agricultural crop recommendation. It now goes to the farmer level, and then it will, based on the inputs given by the farmer, this particular system will tell the farmer what will be the optimal portfolio of crops that the farmer will be able to grow in the next 2 seasons. In India, there are 2 seasons. One is called the Kharif season, another is called the Rabi season. And between these 2 seasons, there's an intervening season as well. So this particular program will actually, this particular mobile app will actually tell the farmer what is the best combination of crops that the farmer can plan to have over the next few seasons. Then we have this promise, which now looks at the procurement of agricultural inputs. So we have done the planning. So then you have to procure the agricultural inputs. When I say agricultural inputs, I basically mean 3 important things. One is the seeds of very good quality. Then you have fertilizers. And finally, you have the pesticides. So these are the 3 most important inputs. So how do I ensure that the small and marginal farmers will be able to cost effectively procure high quality agricultural inputs is what Promise does. And then we have an important module called Prepare. Prepare basically does the price prediction. Now, price prediction in agriculture is actually a grand challenge problem, especially for volatile crops. So what we basically try to do was to use extensions of time series models and then combine them with fairly sophisticated deep learning models in order to predict the prices of crops reasonably accurately. And if the farmers and also the government come to know about the prices, then it's actually going to be good for the entire system. Then, so this is when the crop is actually being grown. And then when the crop is complete and agricultural produce is ready, it has to be harvested. And then you look at the post-harvesting stage where you have to provide an excellent reach to the farmers, to the markets, agricultural markets, so that the revenue that the farmer makes out of agricultural produce is maximized. So we call that as PROSPER, protocols for optimal selling of produce for enhanced revenue. So you can see we have started with crop planning and we have gone all the way up to post-harvesting. And finally, we have what is called AgriVahan. It's a computational platform that we have designed and implemented for data analytics in this specific context of agriculture, using data sets and then imputed data sets, curated data sets and so on, and also all kinds of machine learning and deep learning kind of algorithms. So this is an open platform that we are now distributing to different colleges in India, both engineering colleges and agricultural colleges, so that the students there will be able to get started with data analytics in agriculture almost immediately, rather than having to build and implement their own computational pipelines. So I think that's a big picture of the Grama project that has happened. And then, for all this, data is extremely important, as you will very well know. One of the very conscious decisions we took was to use only publicly available data, because it's not very easy to get data from either the government or from the private companies who actually hold a lot of agri data. So fortunately, we found that there are so many portals that are maintained by the government of India and also the individual state governments in India, which actually put out this data. It is just that this data may not be complete. The data may be noisy. So you had to actually use some techniques by which you can actually curate this data and use that data for all the analytics that you are going to do. So you can see that the data sources that I have listed here, there are many other data sources, but the key data sources that I have listed here, they're all publicly available data. And one of the things that we have tried to do is actually to clean up and curate this data. And we are now in the process of actually releasing the curated data sets, which can be used by researchers and also students. Okay, so what I will now do is to take you through some of these building blocks that I talked about. If I go back to this diagram, you can see that we have crops, acre, promise, prepare, and prosper. What I will do is I'll quickly cover in one slide each crops, acre, and also prepare. And then I will take up promise and prosper for a more detailed treatment, because that's where AI and game theory, all of them actually come together. One of the things I have tried to do is not to put out even a single equation in these slides, so that I don't confuse you with the math behind this. But please be advised that there is quite a bit of math that is going on behind the scenes. Okay, so let's look at crop S. So I'm explaining this with a simple diagram here. This is the map of Karnataka state, which actually has 31 districts. Now on the left side, what I have pictured is in each one of these individual districts, I have actually taken 7 important crops which are grown in Karnataka, and I have actually pictured in each district in what fraction each one of these 7 crops are being grown. So this is the current state of, for example, 2023. So in 2023, that is how these 7 most important crops in Karnataka were grown in each of these 31 individual districts. Now what I want to do is I want to take into account simple things like, can I optimize the transportation? Can I minimize the transportation? Can I optimally utilize all the warehouses which are available? Can I do a better matching of supply to demand in these individual districts? Can I also build in logic in order to take into account imports and exports that are happening? So these are some very simple constraints which will not be taken into account when all the planning is actually done by the individual farmers. So can the government of Karnataka actually look at the big picture and recommend to each district the optimal combination of crops that could be grown in that district, which will minimize the total cost and which will also maximize the total revenue for the farmers? So it turns out to be a very nice optimization problem. In fact, we were able to convert that into a linear programming problem, where the total profit for all the small and marginal farmers of Karnataka happens to be the objective function. And there are all these constraints like logistics, transportation, warehouse management, and so on. It turned out to be a very interesting problem. And then if these crops are recommended by the government of Karnataka and there is 100% compliance by all the farmers, then we found that you can actually achieve a 80% improvement in the revenue of the farmers, right? You don't have to do anything else. You have to only grow a different combination of crops. But then the compliance from the farmers may not be 100%. So we looked at different compliance ratios. Even with 50% compliance from the farmers, you are actually going to make 10% more revenue for the farmers. So now what we are doing is, we did it at the district level. And district level data is publicly available. Now, taluka level data is now available with the state governments. So, working with the state governments, one can now do crop planning at the taluka level, and one can even do crop planning at individual village level and even farm level. It is just that the optimization formulation becomes a huge this one. But as long as you are working with linear programs, you will still be able to solve this problem satisfactorily. So that was the first building block. The second one is ACRE, which is agricultural crop recommendation. Here the input to the problem is, each farmer will say what's the location of the land, how much of land, and what is the soil type, and also some other historical details and so on. Based on that, the algorithm that we have designed will provide to the farmer an optimal portfolio of crops for the next 2 seasons for the farmer. Now, we found that this problem has an analog in financial portfolio management. So, if you are doing an investment portfolio, and there are now very well-known algorithms using, for example, notions like Sharpe ratio and so on, which actually are able to give an optimal investment plan for you or an investment portfolio for you. So what we tried to do was to map the crop recommendation problem into a financial investment portfolio selection problem, and we were fairly successful in that. And by using some of these algorithms from the fintech domain, we were actually able to come up with better crop recommendations for the farmers. So currently, we are now trying to develop that into a mobile app that can be used by the farmers. Then moving on, prepare is price prediction for agriculture. So this turns out to be a grand challenge problem in agriculture. If somebody is able to solve this problem satisfactorily, I think most problems in agriculture can be solved. Unfortunately, the price of a crop, especially in the Indian context, depends on a very large number of factors. We actually factored in something like 43 features on which the price of a crop could possibly depend. And what we did was we looked at the price patterns over the last 10 to 15 years in more than 1,400 mandis in the Indian context. A mandi is basically an agricultural market which is actually run by the state governments. So there are 1,400 plus such mandis in India. So we looked at, this is one problem that has actually been extensively worked on by researchers worldwide. And what we did was, we used the kind of models that they had already used, whether it is time series models or deep learning based models. And we wanted to somehow beat the current state of the art in this area. I think one idea really helped. What we did was we modeled the network of these 1,400 plus mandis as a graph neural network. And we learned the correlations among the crop prices, right, using the GNN model. All that we did was we put GNN also as one of the layers in the deep learning model that was used, and we found that we were actually able to get 15 to 20% improvement in accuracy of the crop prices. But if you want to do the crop price prediction for the next 3 days or next 5 days or next 1 week, it's all very easy. But if you want to do it over the next 1 month or next 2 months, it's not going to be very, very easy. So we're actually looking at long-term prediction of crop prices also at this point of time. Okay, having presented to you these two things, namely the crop planning, then crop recommendation to the farmers, and also price prediction, I will now dive a little deeper into these two models, which I call as Promise and Prosper. Promise is on the input side. How can you make procurement of agricultural inputs more cost effective and more quality assuring for the farmer? That's the promise. Whereas Prosper is when the farmers are ready with their produce, how do you ensure that the farmers will get the best prices for that, and how do you ensure that you maximize the revenue of the farmers is what is done by Prosper. So here what we wanted to do was, here we wanted to leverage the presence of farmer producer organizations. So can we exploit economies of scale which are afforded by farmer cooperatives in order to do procurement and also selling in a much better way? So we studied the problem in some detail, and NABARD happens to be a champion of farmer cooperatives. So we wanted to do some field studies. So so the idea is to harness the power of farmer cooperatives. That's the crux of the idea. What did we do? So we went to an FPO on horticulture, basically mostly flowers, in a place called Anekal, which is about 35 kilometers from IISc. And we actually spent one full day there, talked to all the farmers and talked to the officials of the farmer cooperative to understand how things are currently going on and how some of these things could be improved. We also went to another FPO called Rajaghatta, which is basically on vegetables. These are perishable vegetables. And it turned out that more than 1,000 farmers are part of this FPO. And it's into vegetables, as I said. Again, we studied what was going on in these FPOs. Then we also had to go to a place called New Tarugupet. People who are familiar with Bangalore will know that New Tarugupet is a place where you will not be able to drive even a two-wheeler, right? Because it has hundreds of shops which sell all kinds of agricultural inputs there. See, if you want the scheme of things to succeed, you have to get a buy-in from the vendors or the suppliers of these agricultural inputs also. Now, when we visited these people, we got a variety of receptions. Some vendors were keen to join because they probably thought that by digitizing everything, it will be good for them. Whereas some were very cautious because they said perhaps it may work, perhaps it may not work, and so on. But most people were actually adversarial because they thought that by doing this, their business will be completely destroyed. Well, we were able to convince some of the vendors who were more progressive and convince them that they should participate in the kind of project that we are trying to do. So this was the field study that we did. What were the key observations from these field studies? Farmers are facing challenges both on the input side and on the output side. That's crystal clear. Secondly, intermediaries are holding the sway by offering credit for inputs. See, in the Indian context especially, and I'm sure this is a global phenomenon as well. So we have these brokers or intermediaries. What they do is they will offer credit to the farmers. Farmers are basically marginalized. They are very poor. They are always looking for cash. They are always looking for credit. So what they do is they will offer them credit and give them seeds, fertilizers, and pesticides, but take away 50% of the margin. And then what happens is when the farmer is ready with the produce, the same intermediaries will come into picture and they will say, we'll find the best markets for you. And because they have already given the credit, the farmers are captured by these people, and then they again take another 50% from the farmer. It's like a double whammy. So now, how do you actually now tackle this problem? It's a political problem. It's not an easy problem to solve. But if there is a strong mandate from the government, then perhaps some of these issues can be addressed. So when we did all our research, one of the fundamental assumptions we did was that we have a clear mandate from the government to support, whatever assumptions we made. And then, the farmer cooperatives also need tech support as well as financial support. Right now, they're very small organizations. Unless they have the muscle to actually attract the farmers in the right way, they will not be able to be successful. So I think our takeaway was that the farmer cooperatives can significantly benefit farmers by adopting innovative technology and with a clear mandate from the government. So what we did was to suggest to come up with the following scheme. For example, you look at agricultural inputs. It could be seeds, it could be fertilizers, it could be pesticides and so on. Step number 1, the farmer cooperative will gather requirements from the farmers for agricultural inputs. Let's say there are 1,000 farmers with the FPO. There is a simple mobile app using which the farmer will be able to input, I want 2 kgs of chili seeds, and I want 1 kg of some fertilizer, and I want half a kg of a pesticide. You collect all these requirements from the individual farmers using a mobile app. Now what you do is you aggregate all these requirements. The principle is very simple. You aggregate all these requirements and then put them into some buckets. One bucket could correspond to 500 kgs of chili seeds, for example. Another bucket or another cluster may correspond to, let's say, 1 ton of a particular type of fertilizer. So having now aggregated and also put them into various buckets, what the FPO can do is to bulk procure them from agri vendors. Now, bulk procurement has 2 advantages to it. The first advantage is that you can have volume discounts, because of which the cost will come down. The second advantage is that because you are doing bulk procurement, you have to do business only with leading vendors, high volume vendors. And if you are actually doing business with high volume vendors, even the quality also can be assured. And the farmer cooperative actually can negotiate on quality also. So not only are you getting a better price, at the same time, you are also improving the quality of the inputs that you are getting. Then, so you also, have a mechanism, and in this particular case, we actually suggested an auction, and the vendors were actually willing to participate in an auction, and then the farmers will obtain inputs at affordable cost and assured quality once the bulk procurement is done. So you can see the idea itself is very simple, but the implementation is not going to be that simple, right? Okay, so on the output side, you can do something very similar. So on the Prosper side, what you can do, the farmer cooperative will gather information from farmers on whatever they have already produced. Then they can aggregate the information and put them into buckets, and now they can do a bulk selling. And then, because the farmer cooperative is now able to negotiate with high volume sellers, you will be able to assure better prices for the farmers. So this is on the output side. The principle is the same. The FPO is sitting in the middle here. For procurement, we proposed a volume discount procurement auction, because there are going to be volume discounts, and the vendors or the suppliers are, you're now trying to induce healthy competition among the vendors by making them participate in a volume discount procurement auction. And we got a buy-in from some of the vendors that they will actually participate in this. And for example, 500 kgs of chili seeds. Now, if there are 3 suppliers, they may actually give you a volume discount curve. And now you solve a nice optimization problem to minimize the total cost of procuring all these 500 kgs of chili seeds. Okay, so you can do a similar thing for Prosper on the output side. Now, when you suggest mechanisms like these, right, these mechanisms have to have some desirable properties. And this is where our background in game theory and mechanism design really helped. So one property could be incentive compatible, where you would like to induce honest bidding or truthful bidding by all the vendors or the suppliers. Secondly, individual rationality. By participating in this mechanism, it should not happen that the vendors actually suffer losses. The utility for them should be strictly non-negative. Then social welfare maximization. So you have all these stakeholders here, you have all these farmers, and each farmer has a utility. And you would like to maximize the sum of the utilities of all the farmers, which essentially means you are maximizing the social welfare of the system. Now, in procurement, you should also do cost minimization. Not only should you maximize social welfare, you would like the cost to be minimized. And then when you do the allocation should be fair. It should have some fairness properties. And finally, there could be some business constraints. Like, for example, you do not want to do business with a very large number of suppliers. At the same time, you do not want it to be a monopoly. You don't want to do business with just a single supplier. So all of these are there. Now, if you want to design a mechanism which will satisfy all these properties, you will clearly see that such a mechanism is impossible. It's impossible to design such a mechanism. So you can have desirable properties for the prosper mechanism as well. So now, having come up with this mechanism for cost-effective procurement, the question of designing the actual app and also the algorithms involved, and then deploying this in real world. So that came, right? When I'm coming to the most interesting aspect, Shaurya has already got up, right? So please follow me for the next 5-10 minutes and I will be done. I'll be done. So how does one design and deploy promise? So as the baseline mechanism, we always invoke the victory auction, which satisfies many of these properties that I listed. And but then what happens is, if you look at the mechanism design space, right? If you want to know more about it, you should look at page number 354 in my book. That will tell you more about this particular diagram. So the mechanisms satisfying different properties, you can see that mechanisms that satisfy multiple of these properties, that space will keep on shrinking. And it will also become empty if you have too many properties that you want to be satisfied. So this is a diagram that I'm showing just to impress upon you that if you want to satisfy a very large number of properties, it's going to be impossible. So if you want to make something impossible possible, right? What do you do? If you want to make something impossible possible, what do you do? You will use deep learning. Nothing else. So that's what we did. So what we did was we actually designed a neural network which will design a mechanism which will satisfy as many of these properties as possible, perhaps in an approximate way. So we did all this interesting work. Now, who will deploy this on the ground? Who will go to Rajaghatta? Who will go to Anekal? And then who will actually deploy this? So again, one has to be lucky. I was lucky, and Bharat Electronics came to the scene. So they have a very good team working on agriculture space. Shobharani, right, leads the group. Very dynamic. They said, sir, we will be able to work with you to actually implement the mobile app and also the algorithm and so on. And they were much better than us. For example, when we went to Rajaghatta, the reception we got was not great. Whereas when the Bharat Electronics team went, they were also able to bundle many other value-added services with whatever they were offering as a part of this, and they were convinced. So we actually implemented the mobile app. We implemented this deep learning-based algorithm and so on. We made the vendors to participate. We got requirements from the farmers. We aggregated. We did the procurement and so on. And the pilot was very successful. And I must tell you that we, after deploying this, at the India AI Summit on 12 July 2024, whatever had been implemented by the IISc and BEL team actually got an award for technology excellence in the agri Okay, so now I would like to talk about challenges in deploying this. Unfortunately, I should have taken something from Tamil also, but I will explain to you what is there. The first one is in Kannada, the second one is in Telugu, the third one is in Hindi. So basically, when you approach the farmers, the response that you will get from the farmers is, we have been doing this for hundreds of years. My father, my grandfather, my great grandfather, my forefathers, all of them have been doing this. And why are you coming here and telling me what I should be doing? And there are also many cultural factors. There are also superstitions. And there is also enormous amount of peer pressure on the farmers. So it's very difficult to convince the farmers. When you go to them, they will say, please don't torture us with all these technology and so on. So this is the kind of reception that one would get. Okay, so fortunately, there are a bunch of progressive farmers. And the University of Agricultural Sciences in Bengaluru has done an excellent job. For every district in Karnataka, they have identified 30 to 40 progressive farmers who are very tech savvy. And they are willing to try out technology for the way they are actually doing their agriculture. So you work with the progressive farmers and hope that the progressive farmers will be actually able to influence, right, other farmers. Then, as I already said, farmers are more worried about credit and insurance. That is their primary worry. So if you are able to build in some incentives to the farmers, which will address some of these issues, then I think you will get a better buy-in from all the farmers. And all these problems that we have talked about today, they are grand challenge problems. Today, Professor Wendy Hall was telling us about the Nobel Prize in Chemistry, Nobel Prize in Physics. I can tell you that in about 5 years' time, if somebody is able to solve the price prediction problem in agriculture, there is a Nobel Prize waiting for such a person. That's the kind of a problem it is. These are absolutely technically exciting grand challenge problems that you can solve in agriculture. And these are real problems. If these problems are solved, the kind of benefits that are going to accrue are immense. Then, of course, data. Data, as you know, is the key. The data that is available is not clean. So you have to use fairly sophisticated techniques to clean and curate the data. And you have to get the buy-in from farmers, FPOs, vendors, and government. So I think when we did this work, we have made very convenient assumptions that there will be a clear mandate from the government, the stakeholders will behave in a particular way, and so on. If all of these things will fall in place, then I think things can definitely be improved. And we are working on. I'm now addressing the final year BE students and the integrated MSc students here. There are exciting problems that you can actually work on. For example, if you look at the third bullet here, explainability. Right? Explainability of these models that we have used, right, is a big open problem. And there are many research questions. For example, can you predict the prices of volatile crops over a large time horizon? Can you do dynamic short-range price prediction? Can you do crop planning at the village level and at the farm level, individual farm level? And can you have agri advisories which are highly customized to the Indian conditions and in fact the local conditions? So one of the ongoing projects that we have is on building SLMs and perhaps LLMs, right, which will be very useful for the specific domain of Indian agriculture. And finally, this concept of farmer cooperatives. It's very clear that farmer cooperatives, if they work really well, will be very good for our country and in general globally. How do we make FPOs an integral part of the agriculture ecosystem in India? I think there are lots of exciting problems that one can work on, and it's turning out to be an extremely interdisciplinary kind of a problem also. So there is scope for optimization here. Of course, stochastics, then of course linear algebra, machine learning, deep learning, all your Gen AI, LLMs, and planning problems. I think everything can come together, but with an extremely compelling application like agriculture. With this, let me finish my presentation. Thank you very much for your patience. We'll be happy to take questions.
Okay, we have the mic, please. One second. Thank you very much, Professor Narahari. This is an incredible journey which started from a course that you offered in 2020, covering so many projects and so many students who have worked on this project. And not only the technical aspects, I mean, the way you explain the practical challenges, that going to the last mile and making sure these are actually working in real life, this is really incredible and very, very informative and knowledgeable for us. Thank you. We have time for a few questions. Kindly introduce with your name and organizations you are coming from, and then ask the question.
Sir, good morning, and I'm Ashwini Kumar from Vellore Institute of Technology. Before I ask my question, I would like to sincerely thank you. You were mentioning about lucky to be in favor when you go for a proposal. In 2007, you were on my side when I wrote a proposal to the DST.
Okay.
Thank you. You were the fact member who supported me for my proposal. Thank you very much. I used to say in front of everybody. Thanks, sincerely thanks. So with regard to the question, one point which I was actually looking for is how actually you brought in the game theory principles.
Okay, so I talked about both the procurement mechanisms and also the selling mechanisms. Right? I showed you that diagram, the mechanism design space diagram. When you want to do cost-effective procurement, which has to satisfy cost minimization, social welfare maximization, incentive compatibility, individual rationality, fairness of allocation, and satisfy the business constraints. It's very clear that such a mechanism is impossible to solve. However, I also showed you one diagram on Vickrey auction. So Vickrey auction is like a benchmark auction that you always start with. So it's a mechanism which satisfies what is called incentive compatibility. In fact, what it does is it makes truthful bidding a good strategy for you, a best response strategy for you, immaterial of the bidding which is done by the rest of the agents, right? So incentive compatibility, then individual rationality, and there is what is called weak budget balance. So you can see there are some very nice mechanisms which have been designed by mechanism designers, which do satisfy a certain combination of these properties. So when you now look at either procurement or selling or any market mechanism, what you'll have to do is, for the given practical context, look at which are the key properties that should be satisfied. Now go back to mechanism design and see whether all these properties can be simultaneously satisfied or not. If they cannot be, then what you can do is you can say the first three properties are to be satisfied exactly. The fourth property need not be exact, it can be approximate. Then also mechanism design will offer you some solutions there. But if you have an impossible situation like the one I showed, then of course the only thing that might possibly work is deep learning, but don't ask me how to explain how that deep learning model works.
Good morning, sir. I am Raj Kumar from Master's Students in Theoretical Computer Science from MIT Manipal. Sir, my question is, sir, as a computer scientist, you played a major role in solving agriculture challenges through the Grama project. how do you think computer science can help address the issue of stubble burning in Punjab, which is causing pollution in North India? Could you suggest some ways for upcoming researchers to tackle this problem?
So you can see that I told you that we made some fundamental assumptions about how things will work. So we said we did not get into political issues, number one. We also said that the government will have a clear mandate and it will support, for example, the farmer cooperatives completely successfully, give them enough resources and so on. We also, assumed that the compliance from the farmers, right, will also be reasonable. To give you an example, in the crop planning problem, right, with 100% compliance from all the farmers, the revenues would increase by 80%. Whereas if the compliance is 50%, then the revenues will increase by 10%. Whereas if the compliance is less than 50%, you don't know what is going to happen. So we have actually made some convenient assumptions like this. So it will be very interesting to study, right, how when we relax all of these assumptions, what kind of models will be able to still produce better results for you and so on, right? And here, computer science is not the only thing that is involved. Computer science is certainly involved because these are all algorithms. And you want to make these algorithms as efficient as possible. And you also want to come up with extremely efficient implementations. And if you have a deep learning algorithm which is working for you, you would like to have the best possible architecture, computer system architecture on which some of these programs will run. For example, some of the programs that we develop may not work on a DGX workstation, but may work on something else very well. So there are many computer science issues. In addition to computer science issues, there are so many other issues involved here. Math is involved here. And agricultural engineering is involved here. And there are so many other interesting aspects which also get involved. It's a truly interdisciplinary kind of a subject that will be of interest to students and researchers from a wide variety of areas.
Hi, I'm Priyanka from IIT Delhi. I wanted to know a little bit about the underlying technique that we are using. Did you look this problem or the sub-problem in this area through the lenses of constraint solvers and samplers and so on? The last decade was all about automated reasoning, like there's a scalability challenges that we were able to overcome. So I just wanted to know your view.
So which specific problem are you talking about here?
So there is a property satisfaction optimization that you mentioned, the linear programming that you
certainly. So you can actually apply many of these techniques. So you can see that I am giving you a linear programming problem. So it has an objective function and it has multiple constraints, right? Now you can now complicate the objective function. You can have objective function 1, objective function 2, and so on. Then it becomes a multi-objective optimization problem. Given that you have only say a single objective function, you still have a very large number of constraints. Some of these are constraints in real numbers, some of these are integer constraints. It turns out to be, in general, a mixed integer linear program kind of a situation. And many of these techniques that you are mentioning can always be used here. Which technique will be the best to be used will pretty much depend on the structure of the optimization problem that you are solving, right? In this case, we actually simplified the whole scenario by working with a simple linear programming formulation. And even with a simple LP formulation, we were actually able to demonstrate a fairly significant improvement in the profits of the farmers, right? Now you can make these optimization problems more and more interesting, more and more complex, and invoke the kind of techniques that you are talking about. At the same time, the deep learning models also that you are using for all these prediction problems and so on also can become more and more sophisticated. And you can actually, so you can see there's a scope for many different kinds of people to contribute to this area.
Sure, thank you.
Time for one last final question here, please. Quick one.
Hi, my name is Kaustubh Kanamungo. I'm a PhD student from IIT Delhi. So you mentioned that you are using weather data from multiple sources to create a model. My question is, with climate change happening and it is accelerating, and it has an outside influence on weather as well, are these collected data still relevant?
Yes. So see again, this question is also an important question. However, one of the very conscious decisions we took was to use publicly available data. For example, we used Copernicus system, or we can use the data from the Indian Meteorological Department. In fact, working with the IMD data actually produced better results than Copernicus, right? We are also now trying out with Google Earth Engine, right, which also is able to predict the weather to a very good degree of accuracy compared to all of these models, right? So you have to work with some of these models to do that. Climate change, I think, is a very high-level strategic problem, right? But working with these models itself is producing solutions for you, which can be actually deployed in practice. That's the way we are looking at it. We are being more practical here.